Hello everyone, welcome back to Automation Engineer channel. Today I will continue with the part 5 of the series Simatic PCS 7. I will introduce about the SFC and its component. Firstly, what is the SFC? The SFC stands for Sequential Function Jack. That enables you to configure and commissioning the sequential control system. Typical application of sequential control system involve the processes and the plants with discontinuous characteristic, and that sequential control also can be used for continuous process and the plants. For example, for approaching and withdrawing the full movement, operating point change, and the state change due to force. And the sequential control are implemented for some level. First is device control level. For example, opening the valve, starting the motor. The second is group control level. Proportioning, steering, heating, fueling. And the third one is the unit level. The unit can be a tank, a mixer, a scale, a reactor. And the final one is plant level. For example, synchronization of the units and the common resources, routing. And this is an overview of the sequence. In the sequence, we can have the step 1, step 2, step 3, etc. And in each step, we can have the phase 1, phase 2, and phase 3. This is the overview of the sequence. Okay, the important thing of SFC is the operation state. What is the operation state? The operation state of the sequential control system that indicates the current state that help the operators make decision for operation to continue the current operation state or change to another operating state. For example, in a process with 3 phases, and the current phase is phase 2, and the phase state is run or active. From that indicator, the operator knows the process is running well without error. So just follow. In another case, if phase 2 state is hold due to one issue, the operator will know that they need to solve the issue to make the phase back to running. If the issue is big and need a lot of time to solve, they will stop or abort to restart the process. Okay, next is action of the SFC chart. They are start, abort, restart, hold, complete, reset, resume, stop, and error. And these actions will cause to a different state. The state can be idle, starting, run, or active, completing, holding, error, held error, resuming, aborting, aborted, stopping, and stop. You can see the relationship between action and state in this flowchart. You can see. Okay, I will pointer. You can see we will start from idle state here. And after action stack, this is the action stack. The state will be changed to starting here. And after a certain time or the transition condition is true, the state will be changed to run here. After running, the process will change to completing here with the true transition condition between the step run and completing. We will have the transition here. Okay, I will talk later in the next slide. If the process run normally, after completing, the process will stop and change to stopping here. And after that, it stop. And next, we'll come back to the idle here, this way. Come back to the idle and restart for new cycle again. In case have error in any step, for example in step starting, run, or completing, the flow will follow the red line here. You can see. The red line come to the state error here. And after that, we will have due to the error. And after fix the error, we will resume the run step here and come back to the run state here. That is the hold for error. In case hold for another thing, for example hold for maintenance or lack of material, the flow is the same with error, but we'll go this way, hold, and change to the static holding and held. And resume start, resume and come back to run. In case the error or the issue is difficult, we cannot fix it quick. We need to hold for long duration and it will impact to current cycle product. Or the case the error cannot cover in this cycle, we need to hold and abort this cycle and come back to restart. And that will go with this way. We will abort, hold and abort here. And come back to the idle and restart a new cycle. Okay, that's the overview of the operation, action and state of SFC. Okay, next I will talk about the SFC check components. This is the overview of a check component, SFC check component. First is the sequence. The sequence describes a flow or a sequence of the operation. Example of a production operation such as heating, cooling, filling, mixing or pasteurizing or CAP, etc. It also describe operation states such as running, shutdown, start, etc. In one sequence, we have steps, phase, and transitions. Next is a step. A step is described for a part of the sequence. For example, in the heating sequence, we will have the step named Startman motor and the step named Open safety valve and step named Start burner. That's the example. Next is the phase. Phase is a combination of actions in the step. Each step is divided into 3 phases of action. The first phase is initialization. In this phase, the action will be executed in the first execution of step. The next phase, processing. This action will be executed in the cyclic execution of the step. And the final one, that is the termination. That is the action for the last execution of the step. And about the executing steps and transition of the sequence, the start step is activated when the check is started without query condition and each action executed. A step can have the steps active and inactive. A step becomes active after preceding the transition pass control to it. The actions are triggered and executed. A step becomes inactive after successor transition is satisfied. A transition has the steps 4 and 2 and the stage of the successor transition of the active steps is query. If the successor transition is true, it means the condition is true. The previous step in the active and the next step is activate. In a medium runtime config, the transition is queries depend on the step control mode. Only after this time has elapsed, the action of the end step are executed once only. In one node, 2 steps must be separated by a transition and 2 transitions must be separated by a step. And come back to the check here, you can see this is the start step here and this is the end step. Between 2 steps here we will have the transition. This is the condition to pass from step previous to the step after. And in the step we will have the phase, 3 phase here. Okay, the phase I explained here already. Okay, next I will talk about the types of sequence. The first type is a single sequence. This is the straight sequence from the start to the end, with only one flow, step and transition interleave. This is the main type of every sequence. The second type is parallel sequence. The parallel sequence are executed in one cycle and executed independent of each other. The transition after parallel sequence is executed when on the step at the end of the sequence part are active and the transition condition are satisfied. The third one is alternative sequence. The part of an alternative sequence to be executed is the sequence with the transition whose condition is satisfied first. If several transitions are satisfied at the same time, the transition, the furthest left in the check, is activated. In an alternative sequence, every transition should have the parameters defined at the start of step. Transitions without parameter are on way to and therefore automatically satisfied. This means they are on way to before a transition with parameters. And this is a combination of three types, include the single here, single, include the parallel here, and the alternative sequence here. Okay, that's the introduction of the SFC. Next, I will show you how to program the SFC. Okay, we open the Simatic Manager and come to component view and insert SFC. Yeah, we come to the chart here. Right click and insert new object. We select SFC. Okay, I will rename it. It's the run. Enter. And we double click to open the SFC editor. At beginning, we just have two steps here, stack and the end, and we have one transition, number one here. This is the toolbox of the SFC editor here. Okay, I will go around with the toolbox first. This is the icon for insert, step, and transition, or we can call the single sequence here. And this is the icon to insert the simultaneous branch or insert a parallel sequence. And this is the icon for the insert for alternative branch. This is and next is this is the insert a loop. I will explain more later. And this is for the jump. And this is the text field. Okay, now I will insert a step and a transition into the current sequence here. We click on here and insert here. Okay. Next, I will insert a parallel branch here. I click on this. In case you want to insert one more step in the parallel, we insert a single step here. Click on the single and we drag the mouse here. You can see the ring line, the vertical line here. We click on and so it will insert one more step in the parallel branch. So these step 4, 6, and 5 will be executed in parallel. Next, I will insert an alternative branch. Alternative branch here. Okay. And continue to insert two single steps into the alternative branch. Single, come here and here. It means if with transition 4 or 5 is true first, the flow will go with the next step of that transition. For example, the transition 4, if the transition 4 is true before the transition 5, the step S here will be executed. Okay. Next, I will insert a loop. Here we click on the loop here, and I will insert here. It's quite the same with the alternative branch, but different. Either loop can come back to the previous and before step, and can run many times in the middle of sequence. You can see. Okay, I will double click to see bigger, or we can click here. One more. Okay, I will explain more about the loop. When we do the step 10 here, if the condition 9 is true before the condition 1 or transition 1 here, the sequence will run this way to come back to the step 10 until the transition 1 2 before the transition 9 here, the flow will come to the step n. Okay. Next is the jump. We can select the step. We can select the jump. Okay, I will insert the jump first. For example, insert here. We can with the jump here, we can select the step number. That's if this the transition here, transition number 10 here is true, process will jump to the step we assign here. For example, I will assign step number 9 here. Okay. It means when the sequence stay in the step 7 here, if the transition number 10 here 2 first and before the transition 8, the sequence will come to the step 9 here, and after that we'll go this way. Okay, and the final one is the text field. Here we click on this is due to text something to show or not something. For example, we can put the name of the sequence here, run motor, for example. Okay, just text. Okay, now I will show you the structure inside a step and what a step do. For example, okay, I will click on the step 3 here. You can see the first tab here is a general. In this tab, we can change the name of the step. For example, here I can change the name is the run motor. For example, run the motor. Okay, we click on apply here. The name of the step will change. Next is initialization tab, or we can call initialization phase. All action in this phase will be executed one time when start the step. And next is the processing phase. All action in this phase will be executed continuously until the after transition is true. It means the transition 3 here. If the transition 3 is true, the step run motor will stop and the action in the third phase, in the termination phase here, will be executed one time and we will move to the parallel branch here. Okay. Now I will delete the step and transition here to simplify the sequence. Then I will assign an action for a step and condition for transition. Okay, we can here and we press delete. Yes. Okay. So we delete on. Now I will insert two step and transition here. Okay, one more. Okay, one step for bump and one step for valve. I will assign an action for bump step, and in this video I will let the bump start with the auto mode. Okay, firstly we double click on the step 3 here. I will change the name bump 5121 here. Apply here. Okay. And the same with the step 4, I will change the valve. Okay, I change the valve, double click on this and valve 1101. Okay, and we come back to the bump. Okay, in the initialize tab, I will convert the operating mode of the pump to the auto. To do that thing, we need two steps. The step 1, we double click on here and come to the bump 5121. This is the plan view. We expand unit 1, process 1, and the motor. We come to the bump 5121. And we will select the bit name mostly up. We find the tag name mostly up here. This is the mostly up. And set it to 1. This bit indicated for the switchover of the operating mode. You can see it in the F1 instruction. If this bit E1, it means the operating mode of the pump will be controlled by SFC. And if it's 0, the operating mode of the pump will be controlled by the operators. Okay. And because the data type of this bit is struct, so we right click and we open the structure and we select the value and double click. Okay, and we close. After that, I will compare it with 1. 1 is mean 2. Okay, it will automatically transfer the 2 here. The step 2, we double click on next line here. We select the bump. Okay, and we will find the big name automatically here. This is the bit setting for the auto mode. When it's the 1, when it's 1, it means the bump will run with the auto mode. And when it's 0, it means the bump run with the manual mode. We do the same with the step 1 because it's also in the structure. You can see we right click and open structure, select the value here, double click on it and close. And we also compare it with 2, it means 0. Okay, that's the setting for initialization. In the initialization phase, we just setting for the bump ring with the auto mode. And next, I will setting for the processing phase. I will start the bump. Okay, we double click here. We come to the bump. We find the tag name start auto. We find the start auto as here and set it to 1. Right click, open structure, value, close 1. Normally when starting the bump, that's enough. But to prevent the bump is requested by another command to stop, I will make it will make the bump fall. So I will also set the bit stop auto to 0. Double click here. Spanish unit, the bump. Stop auto. Here. Close. And 0 is mean fall. The data type is the no. Sorry. Delete. Double click. Right, open structure. The file close. 0 4. Next, I will setting for the termination. After stack in the processing, in the termination, I will turn back the operating mode to the operator and initial status of the bump. We come here and firstly, I will return the operating mode. We come the initialization phase here, and we click on number 1 here, and we press the control to select 2 also, and we right click, we copy, and we come to the termination. Right click here, and we paste. Okay, and we change the value to compare here. It's 0. Okay, we do the same with the processing to return the initial status of the bump. It means turn the bump to stop. Processing here. Select bold line. Copy and come to termination. Right click and paste. We change here. Start auto we change to 0. And the stop auto here we change to 1. Okay. Okay, so it's done for the setting for the step. We click on apply. We close. Okay, next I will set in the condition for the transition. We double click on the transition here. In this property window, we can change the name of the transition. But in this video, I will let default. And we come to the tab condition here. We double click on it. And we select the big name. In this video, I will give you an example. I will get the feedback running of the pump to compare it with 1. It means when the pump run, then we go to next step. Okay, expand the unit 1 here, select the pump, find the tag name feedback run out, and here. Okay, this is also the struct data type. Right click, open structure, the value here, double click on it, and close. Yes, we compare it with number 1 here. Okay, in this condition we can select the logic here. We can select equal or not equal, because this is the digital value, so we just have equal and not equal. What's the next line? If we input the analog value here, we can select equal, less, greater, less and equal, or greater and equal here. Okay, we click on apply here. So it's done for the setting the condition of the transition. Final is the condition for operating. The condition for operation jump to this sequence. I mean the sequence run here. Okay, we right click on the name of sequence. Right click and we select the sequencer properties. We come to the stack condition here, and we will input one tag. When equal to 1, we'll jump into this sequence, or we can let the default here. This is the default value. This means the run here, run mean this sequence run, and dot run, this is the property of this sequence. Okay, this line means if the sequence run is running, it will come to this sequence. We can also change one tag here. Okay, I will double click on it, and the units here. For example, I can the valve two-way here. For example, if the valve, the feedback V2 here, open structure, the value, and we change this run 1, can apply, we close. So it means when the valve is open at the position 2, this sequence, the sequence run will run. So that's the programming for the SFC. Hope you can do by yourself. If have any concern, just leave a comment below this video. Don't forget to subscribe my channel to watch more video about automation. Thank you.